Welcome to my presentation, Punishment as Payback in Cooperatively Breeding Cichlid and Pulcher Fish. Cooperative breeding is a type of reproductive system in which subordinate individuals help protect and rear the brood of a dominant individual. This is known as alloparental care. This has been seen in many mammals and birds, such as meerkats and Seychelles warblers, but also in many insect and fish species. For helpers, they incur the cost of territory defense, feeding the offspring, and losing direct mating opportunities. However, they have the benefits of inclusive fitness, lower predation overall, and can inherit the territories of dominant individuals. They can also improve their breeding skills. This leads to the pay-to-stay hypothesis, which posits that breeders have the cost of sharing and competing for resources such as food and mates, and some of the ways that subordinate individuals can compensate for this is by protecting the territory of the dominant individual or their brood. The study I chose to focus on is titled Group Size Dependent Punishment of Idle Subordinates in a Cooperative Breeder Where Helpers Pay to Stay. They took a look at cichlid and pulcher fish. These fish typically live off the coast of Tanzania, around Lake Tanganyika, where they cluster around rocky habitats and colonies. These groups often defend central breeding grounds against predators, and they usually have a couple of breeders and 1 to 25 subordinate helpers. Dominant breeders usually attack the predators, whereas subordinate helpers usually protect and raise the brood. They're a great model system for testing the pay-to-stay hypothesis because they have a low R value, which means low relatedness, which means that their kin-selected benefits are actually quite low, and because of predation, there's not a lot of voluntary dispersal because of a small number of external opportunities. Prior studies have shown that when helpers are removed from their territory and then returned, breeders are more likely to evict these helpers. This led researchers to investigate the punishment and responses of lazy helpers in cichlid and pulcher fish. This was under the main hypothesis of the pay-to-stay hypothesis, which actually predicts that dominant individuals enforce help from subordinates. This led to the specific question, do idle helpers increase submissiveness or receive more aggression, and does group size affect helping efforts or punishment after idle helpers return? To address this specific question, researchers looked at both large and small cichlid groups. They tested the help after a forced idleness period, group member responses, and the effects of group size on these responses. In their first experimental group, a prevented helper, or a helper within a plastic cylinder within their territory, was left there for 24 hours, but was not allowed to participate in helping activities. Removed helpers, however, were helpers that were put within a mesh wire cage for 24 hours away from their territory and also not allowed to participate in helping activities. Control helpers were put within the plastic cylinder within their territory, but then released only after 5 minutes. After the 24-hour period, researchers came back and they counted the number of submissive, aggressive, and territory defense behaviors demonstrated by the fish for a period of around 10 minutes. They also looked at the number of evictions that were seen within the fish. Using these measures, they were able to calculate per capita aggressions from breeders and helpers and use generalized linear mixed models and Fischer exact tests to conduct a statistical analysis. One of my critiques, however, is that they did not properly control for the temporal release in the control group, where there was a period from 5 minutes after they were released to 24 hours when the behaviors were observed, as opposed to in the experimental groups. They also didn't really say what submissive, aggressive, and territory defense behaviors qualified as. Despite this, researchers saw that only idle helpers in small groups actually increased their territory defense. In the furthest left plot, we have defense behavior on the y-axis and comparison between control and the prevented help groups, and we see that only the triangles, which represent these small groups, actually increase in defense behavior, while the circle groups actually decrease. All focal helpers, however, did increase in submission and received aggression. However, this was much more seen in the larger groups noted by these circles. They also noticed that group territory defense actually tended to decrease, and that smaller groups actually had the greater number of evictions. As for the causes of aggression, they saw that small group idle helpers actually received most of their aggression from breeders, signaling punishment. And in large groups, idle helpers that returned actually received most of their aggression from similar-sized helpers, alluding to competition for rank. Only removed helpers were actually those that tended to be evicted. This study was actually quite successful. In their discussion, they state that at least in small groups, breeder punishment is likely the main function of elevated aggression, which would explain why idle helper territory defense actually increases due to fear of punishment, and that evictions are greater for small groups because breeders in these groups are very attentive. In large groups, however, rank competition is likely the factor. This explains why aggression mostly comes from similar-sized helpers. This leads to the question, though, why are large group breeders not as aggressive towards lazy helpers? And this most likely comes from cognitive limits on being able to track all the individuals in the group, and also probably diminish benefits from punishing these helpers. Other studies I read, however, suggest other reasons for these behaviors. Zottel and Alt showed that breeders are actually likely to accept foreigners and not evict them when there's a risk of predation that might make it more beneficial to do so. Bayani et al. Also showed that there's a proximate mechanism for increased aggression, which likely comes from when Pulcher fish actually urinate, and there's a type of chemical signaling that goes on that actually increases aggressive behaviors. This has many ties to principles in cooperative breeding in a larger theoretical framework. As has been shown, helping can be a decision. Seychelles warblers, like many other helpers, evaluate the potential costs and benefits associated with helping. When their parents are replaced, they actually choose to disperse because they likely receive less of an indirect fitness benefit, and it's not favorable for them to stay. Breeders also have decisions to make, and like Emlyn et al. Showed, white-fronted bee-eaters pictured here can use aggression to enforce helping in younger relatives. And much like in this study today, I wouldn't be surprised if when these expectations are not met, punishment can enforce this helpfulness. And breeders also have another tactic up their sleeve. They can use eviction to threaten helpers. Overall, this study is very important for understanding cooperation in a highly social species, where unrelated individuals help dominant breeders to raise their offspring. Thank you.